We received a call last week from one of our end users that had implemented Woodworking for Inventor last year. He was very satisfied. He indicated to me that not only were they more productive than they've been in the past, but they've also increased their accuracy, speed, and quality of the whole manufacturing process, not only in the engineering department, but also on the shop floor. Now, those calls I love. They're great. But that wasn't the reason he's calling me. I'll take those calls every day of the week, but he wanted more. Call to action. How can we help this account? They want to improve. Management says we want to improve. They're going to allow the users the time to learn, educate themselves, change their workflows. Workflows. That is the key. Not only the change of the approach to how we do things, but also to use some of the tools you've shied away from, or many accounts have shied away from, because they looked like they were too difficult. Well, Inventor's not a difficult tool. Many of our accounts have reached that state, follow the same guidelines, and have seen dramatic increases of their departments. Instead of hiring new people, they can use the people they have. We decided to put together an example that hopefully will show the methods that we're describing. We have a carcass made up of multiple parts. We have a face frame made up of multiple parts. Both of them are independent sub-assemblies. And of course, then we have the joinery, what allows us to attach them together, not just constrain them together, but some sort of joinery, some woodworking joinery. A little bit of housekeeping. All the software that we are showing today is available on a download and a free trial. The URLs are available online, as you can see, and the demo set that we developed also is available by contacting us. What have we seen? Standards or loose standards of catalog systems where our customers have created independent parts and independent sub-assemblies that are put into a folder, then they're brought into an assembly you're working in and reused over and over again. Customers that have created I-families and I-parts and model states that extended its capability a little bit further, but still pretty much standard in terms of the ability to globally change. We have other individuals and customers that have created more part development and assembly development systems that start using Ilogic or spreadsheets to control things. And then hybrid, of course, between all of that. Our session today is going to be a little bit different. We're going to use two totally independent subsystems and tie them together to be independent and dependent at the same time. Again, we're going to start using joinery now. Okay, joinery that will allow us to bring in either store-bought components, components we create, that will give us accuracy and speed and quality, not only in the development of pilot holes, but also in its location. And of course, the usage of different types of joinery. If the product's already done and we need to switch it from biscuits to pocket screws, or pocket screws to dowels, or lock dowels, how can we automatically change everything in a job that's already been created? So, that is our goals for this afternoon. Goals: accuracy, speed, quality. Let's get started. We can approach this project by first discussing some library items. This carcass is a library item. Very flexible, always based on the way we create. The joinery we use, the connection points we use, dimensional information we use. So step one is to set this up, but also make it so that it is very variable. So what do I mean by that? Well, first of all, the basic construction shows you clearances that are already in place, back panels, side panels. What I don't show is the actual joinery itself. Let's go into wireframe and you can see that. So really no joinery here, no dowels or biscuits, pocket screws, nothing, but obviously we do have clearances. We've always suggested to all of our end users start using Ilogic, and in our Ilogic forms you could see that there are many ways of augmenting this particular unit itself. Changing the width of it from 40 to 32, obviously you see that it is fully editable. Depth and height, core thickness. Core thickness refers to everything but the back panel. And if I change the back panel here, and let's make it 3/8 of an inch, 0.375, you can see it's adjusted completely, but also maintain clearances. Very important on the machining side of things. Also in here, you'll see that we have the ability to change this vertical panel. Right now it's set at 12 inches. Let's make it 15 inches, and it's adjusting as we go. So the point here is build your libraries in a way that will allow for you to change them comfortably the way you might think that jobs of your nature, the nature of your company would work. You're not going to catch everything, but you can most likely get 50% more than a standard library item that's very difficult to change. The other thing that we try to do is think for the future. Think of what the end result might be. So that is why you'll also see this, what I have added here called face frame joinery. And in face frame joinery, we have, 4 different configurations. No joinery, using pocket screws, using biscuits, or using lock dowels. So if I say I want to use biscuits or pocket screws, you can see that all the pocket screws have just been added to this particular model. And of course, by changing the width of the unit, then the pocket screws adjust accordingly also, maintaining center lines and maybe 3 or 4 inches from each side. If we didn't want pocket screws and we wanted biscuits, of course, we're now changing them to biscuits. Or of course, lock dowels, and we see we have lock dowels. Now, what I don't have is, of course, the actual pilot holes or the construction that needs to be machined. So I'll go back to pocket screws, which is what I've just done. And what I'll now do is sculpt it. And what sculpt does is it adds all the pilot hole information that's necessary. Fairly straightforward, I would think. And let's turn the shading off so that you can actually see the reality of what it's going to do. And now whether or not you machine on a CNC router or this is just for location for the shop, it really doesn't matter. It's just very simple in terms of the creation of this data. If we didn't decide on having pocket screws, we wanted biscuits. You can see we have biscuits, but the holes for the pocket screws still exist until I sculpt again. And then the pilot holes for the pocket screws go away, and the pilot holes or the pilot boring for the biscuits then gets added. Let's just take a look at that, and I'll move one of these so we can see it. if we plan for change when we know most jobs do change, then the result is a much more efficient, more accurate, and a quicker process to our end result. Looking at the end product or considering the end product first allows us to build into our Ilogic forms some of that capability. Now, one other function that I've added to this carcass is considering whether or not the ends are finish ends or non-finish ends. And a finish end and a face frame, we might want to miter the sides, the left side and the right side of this particular unit. But if we do that, then the actual joinery might change. So what we've done here is when I've listed finished ends, I'll have several choices. None, which is what you see here. Left only, right only, or I want both finish ends. So if I pick left, the finished end on the left-hand side of the panel just changed to a miter. That will accept a face frame that's mitered. Notice that the joinery turns off. Maybe because we're going to use different types of joinery, or no joinery, it's going to get glued. Whichever way we determine our design. Same thing is true here, finish end. Let's say the right side, and now the right panel changes, brings back the joinery on the left, and so on. So again, you could see here that we have that built into our system. You can create multiple configurations here. You can add really an infinite amount of possibilities. Today's session, just want to show you some of the capability, and your imagination will take you to the next step. Right now, simple carcass, it doesn't necessarily have to go into a library. It's sitting in its own folder somewhere. And my goal now is to use it over and over again and not worrying about copy design and it linking back to the original library item. Because we know that if you change the library item, it changes it everywhere it's used, and we don't want that. What is our approach? And this is workflow. This is everything we've been talking about. How do we now implement that strategy? So step one is to take a look at the parameters that you've built already. So I'm going into my parameter list, and I know down here, these are the parameters that I'm using within our Ilogic form. The ones that I want to be prompted for, because maybe I don't want to be prompted for everyone, are the ones that I have created what are called key fields. Key fields are fields that have unchecked boxes usually, and by checking the box on or off, it is telling the system that we want to be prompted for those particular parameters. So that is step one. Pick done and save our work. So the second item that we need to do is to stabilize, it's called, stabilize the names of our parts in the browser. Not in Windows, not in Windows Explorer, but in the browser. These names are very important not to change because our Ilogic rules use these names, and if these names have been changed, then the rules don't match up. So under the Ilogic tab, we have something called external rules, and external rules will allow us to look into a folder on the network or on our local machine to find the different rules that have been preset that will allow us to run them independently of whatever file we're in. So we have a file called stabilize, and if I right click and run it, what it's doing is locking up the file names so they don't change when I bring them into a new assembly. The stabilize tool is nothing that gets shipped with Inventor. If you are not aware of it or you need it, please just get in touch with us and we'll, of course, email it over to you. So those are the two areas that we need to address. And, of course, you pick save. And that is our finished step to the carcass or to any subassembly. Testing on the individual subassembly. We've accomplished our task up to this point and we saved our work. Let me exit out of this. I'll exit out of the face frame. I'll pick File, New. And let's create a job. Let's create a standard assembly. I'm in a standard assembly now and I'm picking Save. And I'll create a new folder. And we'll call this, Job 101. And the Job 101 folder will create a top level assembly and I'll call it Room 1. So we're now in Room 1. Now, everybody does this. What is the difference between what I did and maybe what you might have done? Well, in our world, I already have parameters associated in the top level assembly. Assembly width, assembly depth, assembly height. Okay, these are what I'm going to call global parameters. Parameters that will follow any assembly that gets put into this job. Maybe it's global thickness. Okay, you want to change the thickness of all the cabinets at once, all the fixtures at once, because the material that came in was scant and you need to adjust it and all the joints need to be adjusted. Again, workflow is the key here, thinking ahead. So you'll see that these are very common names, and think of it, if you're an AutoCAD user or have been, they're like layers. They're sitting there waiting to be used if one wants to use them. And of course, they're key fields, items that will be prompted for. So it's sitting here just waiting for us. In the blank assembly that we just used as the template, we also will have a form called global parameters, or again, whatever you would like to call it. And those global parameters are now listed that if we change these, it'll change it on all the different component subassemblies or parts that we bring into Room 101. So cabinet A, B, C, D, and so on. Again, changing workflow. To take advantage of this workflow, there's certain do's and don'ts that we always suggest. First, we don't use the place command. Place command is something that everybody's comfortable with. It is the method that allows you to take a subassembly or parts and bring it into your assembly at this point and then constrain it. If we do, it's a one-to-one relationship. Library part as is to, of course, the assembly we're in. If we do it again, it's the same thing, same copy or instance of the original. Change one, it changes both. I want flexibility of bringing one in, bringing another one in, changing one without changing the other. So what we do instead is use place Ilogic. When we pick place Ilogic, we still, the workflow is similar in the fact that you have to go find the assembly. And instead of it just being dropped in, it's going to prompt you for all of the parameters that were in that subassembly, as you can see over here on the left-hand side of the screen. You can see that here are the parameters that were key fields. If they weren't key fields, they're not going to appear here. Second field, or the second column, is the unique parameters that are built into that assembly. Unique. The third column is the global parameters that we have defined within the template file that we started with and they're sitting here. So the assembly width, which probably I want to be able to use a global parameter, because if I have a carcass width, I want the frame to equal the carcass width. Two independent parts, or I should say two independent subassemblies working together with really minimal linkage. So I'll click on this. I'm going to say that's the assembly width. And you can see here that it's set to 24 inches. So 24 inches, of course, is what you'll see here. That'll change. Okay. The assembly depth, which is unique to each individual cabinet, let's make it 18 inches. So that's not going to be a global parameter. At least I don't want it to be at this point. Assembly height, I'll leave alone. Thickness, yeah. Thickness of material will be thickness 1. Okay, thickness 1. That allows me to have multiple fixtures in a top-level assembly, and changing it in one location changes it for every single fixture. That is set at the moment to 1 inch. The thickness of the backs, which I call thickness 2 for the moment, is thickness 2. And you can see it adjusted it here. Of course, we're going to change this. Vertical 1. That is the location of this vertical measured from the inside of the left panel to the inside of this vertical panel. And let's make that 12 inches right now, 12. And that's now done. Do we want to add joinery to this globally? Maybe, but let's not do it globally. Let's go ahead and say joinery should be biscuits. And now those have been adjusted. I don't want to do any finish ends at the moment, so I pick OK. And what this is doing now is it's building it, creating all the files associated with it, and I'm now placing it in room 1. Right click and I'll pick OK. If I change the assembly width from 24 to 40, that's a global parameter, and that just changed. And I'm going to pick save and save my work. So I brought the first item in, first subassembly in. If I want to verify and test it, obviously I can pick bill of material, and we have 3, 6, 12 lamellos here. So you can see here's the first carcass. Here are the parts that make it up. There's 12 biscuits. All the sizes are what we want. And, you know, this back is a little too heavy. Let's change the thickness of that back to 3/8, 0.375. And that's now changed. And if we go into, of course, our bill of material, the back will be adjusted, as you can see here, 375 back panel. Some of these things I'm showing at the moment are, we went over some of them in previous seminars. If there are any questions to what I'm doing, please get back in touch with us. We'll be happy to show or present or send you some of the older seminars that we've done. So let's prove this out. I'm about to create another unit that is totally independent of the original, that also can be linked to the original. So place, again, Ilogic, grab the original carcass, or a different one if you wanted. Same environment pops up. It's prompting you for information. Here are the fields for global parameters. They're not associated yet. These are the fields for the unique parameters per part. So the assembly width, I'll say assembly width. The depth of the cabinet, I'll leave it full. Height, I'll leave full. Thickness, I'll say thickness 1. Okay, so we're going to control the width globally, the majority of the thicknesses, either in the backs or the rest of the units themselves. This vertical, I'm going to say is 10 inches. That won't be global. The joinery this time won't be pocket screws. Well, let's say it's a frameless cabinet. We're going to leave it as is. Let's say this cabinet didn't even have a vertical divider. So we'll say I don't want any vertical dividers here. Total change. But the items that are controllable will be these 3. And I pick OK. And I place it. And pick Save. Some simple testing. These are 2 unique units. They don't share any common parts at this moment. So if I activate this part, or this cabinet, and let's do something with this, okay? So let me just do a simple offset on here, okay? And pick Save. Then you can see that I changed this unit here. It had no effect on that. Let's go into a bill of material. Bill of material. What do the bill of materials look like? Well, it is saying that I have 2 caucuses, caucus 1 and caucus 3, or caucus 2, whichever I named it. And you can see they're 2 totally unique units. If I want to nest it, simple nest. You can see there's 12 biscuits here, no biscuits there. If I wanted to add something to this, for example, finish ends on this, anytime I can just double click on it to activate it, go to the caucus, finish ends, both. As you can see, they're now finish ends. And again, they have no effect, really have no effect on each other at this moment. What's the payoff? I know what my client was looking for. I believe I do. He asked me for quality, speed, accuracy. He needs the functionality of a department that could be more efficient than what he has at the moment. He wants to grow his department. And I'm hoping to show you that some of these workflows allow for that. We have 3 global parameters that we are controlling at this moment. Of course, we can have more. We have the width being controlled, the major thickness, and the back thickness being controlled. And all the others are being controlled independently. So you have a job with multiple fixtures in it, and you want to globally change all the thicknesses at once for the core and all the thicknesses for the backs at one time, and all the joinery change all automatically. Yeah, that's what we are doing here. And when you're asked to do this and it's 4:45 on a Friday afternoon, this is not 2 hours. You're going home on time. This is 2 minutes worth of effort. Let's uncover where the changes are. In the model itself, in the browser, you'll see the 2 caucuses. It uses the name of the caucus to spell it out. In the browser, that is. The first one and the second one. In Ilogic rules, it also creates a rule for you. If I right-click on that rule and pick Edit, The rule is already being created for you. It is saying the parameter within the carcass 1, called assembly width, equals a global parameter. And it's saying exactly the same thing for carcass 2, development 2, assembly width equals that. So this is the hook right here. Very, very straightforward. So let's make this work. You know they're independent of each other. So the assembly width is not going to be 40. It's going to be 55. They both adjusted, and they're independent of each other. Okay, you can see that all the information has changed here. Okay, where the biscuits are. Let's change the thickness to 1 1/4. I know that's heavy, but I wanted to show you that. Everything is now 1 1/4 thick. And the back thickness, I'm going to make it 1/8 of an inch, 0.125. And you can see this adjusted to 1/8 of an inch, and this has adjusted to 1/8 of an inch. Again, let's make this 3/4, 0.75. And on this particular unit, I'll just double click on it. I'll go into the form, go to the carcass, and tell it that I want different joinery now. First of all, I don't want finish ends, and I would like pocket screws. And I'll sculpt. Sculpt will create all the pilot information for machining, or for drawings for layout. So you can see all this is done, and it has no effect on the original here. And when I go out to a bill of material, you'll notice that in the 2 unique bills, okay, this is an indented bill. You can see we have pocket screws here and biscuits here, 12 and 12. So let's try to sum this up. We have a carcass. You see all the control we have over it, either dependent or independent. And we have a face frame that is set up pretty much the same way. I want to put them together this time, totally independent subassemblies associated together. So step 1 would be, what is the connection? How are they being joined? So let's go ahead and check the joinery out. I'm going to put a lock dowel as my joinery. Okay. If I sculpt this, it's going to drill all the holes associated with at least half of that joint. Let's go ahead and move one of those so we can take a look at it together. See, on one side it's going to drill, the other side it's a press fit so that the whole face frame can be just snapped in place even without glue, and it'll hold. So these are just, again, some of the fun fixtures that are available. So we have that done. Let's bring the face frame in. So again, it's not place, it's place Ilogic. We'll go to the face frame folder. Let's see the large icons. You can see that this is the face frame. It's going to prompt me for information right now. Okay, so the information it's prompting me for is, what is the height? Independent, dependent, global. What is the height? I'll leave that alone. What is the width? Well, the width is going to be the assembly width. Okay. What is the thickness of the material? That's fine. We can leave it at that. What is this horizontal opening? Well, let's make that 4 inches for the moment. So these are independent. This vertical, I want to be dependent, so I'm going to go ahead and pick the dependency variable. and pick OK. Bring it in. Right click and OK. And let's pick Save. Now, we do have built in right now bill of material that will show the face frame. So let's go to bill of material. Let's take a look at it. Okay. Here's the information associated with the face frame. Okay. Now attaching it. In previous seminars, we showed you ways of using iMates and automating the attachment process. And I don't believe anything is quicker or more standardized for the department. So it's a tool called Attach. I pick Attach and I touch it, and it prompts me what to do. Select the face I'm attaching it to, which is here. Select the top I'm attaching it to, which is here. And select the right-hand side I'm attaching it to, it's here. And that's now done. And pick Save. How can that is so consistent for everyone in the department to build the same way, constrain the same way. Again, more tools available to us. If we take a look at it from top view, you can see that these are, might have, let's see what we have here. Why does it look like I have a scribe? Let's take a look at that. Activate the part, go into the form, scribe left and scribe right. If this was a 3-inch scribe, nope, got a 3-inch scribe there. Well, that should have been 0. And this should be 0. No scribe, unless I want it, of course. Dependent or independent. Again, let's look at it now. Perfect fit. Perfect fit. Again, lots and lots of tools here for us to evaluate on how we want to approach a different workflow. Okay, global variables now. Assembly width. I'm going to make the width of this unit 50 inches. Face frame changes, carcass changes. I want to change the vertical here, okay? Vertical panel location is 12 inches. This is a 12-inch opening. I'm going to make it an 18-inch opening. Nice and clean. What if I want to change the actual face frame joinery, or I want to change the vertical divider on and off? All of that is still available to you. I'm going to pick Save. And now I want to machine the back side of the face frame. Let's go ahead and sculpt. So just processed it. Let's open it up into its own file. Let me flip it over so we can see it a little bit better. And these are, of course, the lock dowel connectors that can go directly out to machining. And these are not assembly features. If I open up any of these independently, you can see they're at the part level, so they can be machined either manually, meaning with like a Festo device, or more direct on a CNC router, or any kind of boring tool. Okay. Let's go back and look at this. Okay. Looks good. I hope you found this seminar today interesting. It is our goal at Woodham Associates to provide unique workflow solutions to assist woodworkers to improve the way they engineer and design products for manufacturing. If we can help in any way, please get in touch with us. Emails have been posted. If you have a comment or even a suggestion on what the next presentation might include, please call. Thank you once again for attending. A little bit of housekeeping. All the software that we are showing today is available on a download and a free trial. The URLs are available online, as you can see, and the demo set that we developed also is available by contacting us.